presenting your PK project milestone or progress.
Sir, can we use just one device to present?
Yes, of course. You cannot use 4 devices, right?
Dan no, I mean like gantian gitu. Ngomongnya di satu device.
You use just one device. You want one presentation. The question will be to each of you later.
One user, just one user, sir. I mean like nanti kita gantian gitu. Jadi sirnya
No, no,
bakal.
no. Each of you four have to be online because later we will do discussion, but the presentation is just one sharing from one computer.
Oke, sir.
So good morning, Pak Dedi and friends. So today we are going to present our project, our PKM, which have the title of pembuatan asam polilaktat dari bonggol pisang sebagai bahan baku benang bedah biodegradable, or synthesis of polylactic acid from banana hump as the main material of biodegradable surgical suture. Next. So first, next, surgical suture is a very important medical device. It is used in many kinds of medical operations, or to seal on, even without any operation, we could also use surgical these sutures to seal wounds, to seal tissues. So surgical suture is also versatile and it is commonly used. And the most important properties of surgical suture is it is biocompatible. Next. So we have known that surgical suture is very important in the medical world, but there is still a problem in Indonesia. So this is a news that I have obtained from the internet. It is from 2015, and the title is 94% of surgical suture is still imported. So Indonesia imports their surgical suture, and as we have known that we have so much population, then it means that there is a high demand of surgical suture, and that high demand create a high cost also. So next. So also in the same article, I quote something that it is said that we could decrease the expenses of surgical suture if we could produce the suture ourselves. So because there will be no import taxes. So next. So our main aim of this paper is to produce a naturally derived surgical suture which is affordable and reliable. Why naturally derived? Andi, balik Andi, not yet. Why naturally derived? It is because in Indonesia has an abundant source, natural source. So yeah, we would like to make use of it. And also, we also want to make this surgical suture to be affordable, which means that it will be low cost and also reliable, which means that it will have the same quality as other surgical sutures. So we decide to use banana hump as our surgical suture material. Next. Why banana hump? Because it is abundantly found in Indonesia. Like actually it is a waste from the banana tree. So if we can use the banana hump, we could also decrease the waste in Indonesia, waste of trees in Indonesia. Next is banana hump contains starch, and the starch from the banana hump will be the thing that will we convert into PLA. So our surgical suture will be made of PLA. Why do we choose PLA? Because it is biocompatible and it is biodegradable. It means that after we use the suture to do an operation, there wouldn't be any need to take the suture out of the body again after a few period of time. And it is also an innovation because it is not commonly found anywhere, this type of surgical suture. Next. So these are some comparisons of the suture properties of other sutures with PLA sutures, because the PLA sutures is still not commonly used. I have found a paper that has tested some properties of the PLA sutures. So they made a size 5 PLA sutures. Size 5 is the standard from the USP, the United States Pharmacopoeia. It said that the sutures, they said that the sutures have a tensile strength of 12.5 Newton and a not full tensile strength of 7.33 Newton. And if you could see from the table that are provided, the PLA sutures is nggak kalah bagus gitu. Could also compete with the other type of sutures. Next.
Now we're talking about basic principles. Next. So we follow three of the previous research. The first one is synthetic bioplastic dari buah mangrove. So the aim of this paper is to make a plastic substitute using synthetic of bioplastic, which is polylactic acid from mangrove fruit. That means that we can use starch because mangrove fruit also have starch. So we can use starch as to be PLA. And then next we also so
Your voice is
okay, hello.
missing. Yeah, okay. Now okay.
Okay, so next we go to the pembuatan benang operasi dari eceng gondok. We follow this paper because the aim of this paper is to study the effect of polymerization reaction time on PLA yield and effect of PLA compared to glucomannan composition on mechanical properties of surgical suture. So we follow this paper to make how the surgical suture, because eceng gondok also use PLA. And then next is optimalisasi pembuatan polilaktat asam laktat tanpa katalis, because why do we follow this paper is because the polymerization is easy to be followed compared to others research. So the aim of this paper is to measure the optimal temperature and time for formation of PLA molecules. So next. So now we will discuss a bit about the literature review, which is banana tree, glucomannan, polylactic acid, hydrolysis, polymerization, fermentation, and also wet spinning. Next. So first we will discuss the banana tree for short. So banana plant is the monocot plants which can grow every years, and there are abundant number of banana in Indonesia. And each part of the banana has lots of the benefits for treating various types of diseases. One of them is the stem. We have two types of stem, which is pseudo stem and real stem, or we can call it banana hump. And the hump contains 76% starch and 20% water, and the rest is like proteins and also vitamins. And the content that we really want is the starch, which is 76%. And the banana type that we want to use is banana kepok banana, because it has higher amount of carbohydrates compared to other types of banana humps. Next. So because we follow the second paper that I mentioned before, it's contain glucomannan. They combine glucomannan. So the function of glucomannan is to make the solution become more viscosity and elastic. So glucomannan is the polysaccharides composed of the mannose and the glucose. And glucomannan can crystallize and form a fine fibers structure, which often referred as glucomannan floor. Next. Sebelumnya, polylactic acid. This is the important part of the solution that we want to create. So polylactic acid is an aliphatic polyester composed of lactic acid monomer, and PLA has properties like biodegradable, excellent biocompatibility, and it also has great mechanical properties. It has great tensile strength and others. And one thing for sure is PLA can be made from starch, and starch can be found in the plants. One of the plants is, as I mentioned before, is banana, and it has to go through series of processes such as starch isolation, hydrolysis, fermentation, and also polymerization. And when we compare to commercial synthetic PLA, which is monofilament used for surgical suture, it has molecular weight of 50 to 200 kilodalton, and the best tensile strength that I found is 3.1 until 12.3 Newton. Next. So one of the process is hydrolysis. So hydrolysis is any chemical reaction where a molecule of water breaks one or more chemical bonds. In this case, the starch will be broken down into maltose, dextrin, or glucose. Next. Another step is polymerization. This is the important part of our step. So polymerization is a reaction carried out by combining monomers in chains to form larger molecule structures or polymers, so like big chains like that. And polymerization process can be divided into two, which is condensation polymerization and addition polymerization. So condensation polymerization is combining monomer in which two or more functional groups are involved and release small molecules such as water. And additional polymerization is formation of polymers by joining monomers in chain without the releasing of small molecules. Next. And fermentation. This is one of the also important step, which is fermentation. Fermentation is an anaerobic chemical process that uses certain enzymes produced by microorganisms to break down complex organic compound into simple products. However, in this research, we will use acid to we use no. We will use bacteria, which is that produce lactic acid, such as what is the bacteria name? Lactobacillus bulgaricus. Next. Wet spinning. Wet spinning is a technique for spinning yarn from molecules. So wet spinning is usually used for polymers that are not melted and can only soluble in non-volatile and thermally unstable solvent, and can only be removed by chemical. And in wet spinning, the polymer is dissolved in solvent, and then the solution is frozen in the ice bath to produce yarn. So how does it work? Actually, the way will be explained by Anjali, but so I will not discuss it double. So the reason why we use wet spinning is because it's simple and it is affordable. So basically, we will create this kind of arrangement. There are syringe pump and also syringe ice bath, and also the rolling part to yarn the spool to yarn the suture. Next.
So now we discuss about materials and fabrication. These are the list of equipments that we need in conducting this experiment. Next. And here are the materials. Next again. So the first step is to isolate the starch. So after the banana hump is already obtained, it is then cleaned and chopped with a knife into smaller pieces. These small pieces were then soaked with water added with natrium metabisulfate by a scale of 0.2% water, meaning that for every liter of water, there needs to be 2 grams of natrium metabisulfate, and it is soaked for 30 minutes. After that, it is dried under the sun and then mashed into powder and strained using the 60 mesh sieve. After that, 50 grams of the powder is soaked with 100 milliliter of water and left for 24 hours until suspension is formed. And then the suspension that is formed is the obtained starch, which will be filtered and dried under the sun. After that, the starch is dried further in an oven for 60 minutes with temperature at 80 degrees Celsius. And then it is pounded and strained using the 60 mesh sieve. Next. After the isolation, the starch will be hydrolyzed. So 20 grams of starch will be blended with 450 milliliter of water. The ratio of starch to water has always have to be 1 to 22.5 until it is homogenized. The homogenized solution is then placed in a beaker glass and added with sodium chloride with pH 2, and then the solution is heated for 60 minutes at temperature 80 degrees Celsius and then cooled. This process produces glucose. And next, after the glucose is produced, it is fermented. The fermentation uses 1 test tube of Lactobacillus bulgaricus bacteria put in an Erlenmeyer flask containing 10 milliliter of hydrolyzed glucose solution. The flask is then incubated for 8 hours at 45 degrees Celsius. And then 90 milliliter of glucose solution from the previous hydrolysis process is added to the incubated solution. And then the solution is incubated again for 8 hours at 45 degrees Celsius. After that, the incubated solution is again added with glucose solution from hydrolysis process. This time it is 900 milliliter. So there is eventually there is a total of 1000 milliliter of incubated solution. And from this incubated solution, 150 milliliter is taken and added to 1500 milliliter of glucose solution from the previous process, and then incubated for about 72 hours at 80 degrees Celsius. And this process is the one that produces the lactic acid. And there's also a side note that at every incubation step, the pH of the solution has to be made 5 by adding sodium hydroxide. Next. After the lactic acid is produced, it is polymerized. So 100 milliliter of lactic acid is placed in a beaker glass and then heated at 120 degrees Celsius for 1 hour. And after heating, the lactic acid is further heated in an oven at 150 degrees Celsius for 24 hours. And then the obtained lactic acid, PLA, is cooled at room temperature and then dissolved with chloroform. After that, it is sedimentation is done using methanol. From this process, the precipitated PLA is then dried at room temperature until powder is formed. Next, so after the PLA powder is formed, it is characterized. First, the functional group is analyzed using Fourier transform infrared spectroscopy. And then the molecular weight and PLA yield is also measured. So the molecular weight measurement is done by calculating viscosity of PLA. First, the PLA is dissolved in ethyl acetate with concentration 0.5, 0.2, 0.3, 0.4, and 0.5% at 25 degrees Celsius using the Oswald viscometer. And then the viscosity is calculated using the formula relative viscosity equals to time of sample divided by time of solvent, and specific viscosity is equal to relative viscosity minus 1, And reductive viscosity is equals to specific viscosity divided by concentration of PLA. Next. And the intrinsic viscosity is plotted using PLA concentration as x-axis and reductive viscosity as y-axis. The molecular weight is then calculated using the Mark-Howing equation, which is concentration viscosity concentration equals to K times mv, which is the molecular weight, to the power of A. The K and A values depend upon the solvent and temperature at which the experiment is done. For ethyl acetate solvent at 25 degrees Celsius, the K is 1.58 times 10 to the power of -4, and the A is 0.78. Next. Next. Oh, and then the suture is fabricated using the wet spinning technique that is previously mentioned by Ezra. First, the PLA powder will be dissolved in chloroform, while the glucomannan is dissolved with water. And then the two solutions are mixed with the ratio of PLA to glucomannan equals to 3:1 in order to obtain suspension. Then the mixture is loaded into a syringe pump. The syringe pump is turned on so that the suspension is sprayed out to the aluminum tank that contains isopropyl alcohol, short alkenes, which we use as hexane and heptane, PEG, polyethylene glycol, and amphiphilic polymer. In this case, we use the amphiphilic polymer we use is betaine, and the thread. And after it is sprayed out, so the polymer will be coagulated by this by the contents of the aluminum tank, forming a thread, which is then pulled out into the spool to form the and we obtain the thread. And the thread that is obtained will be kept in a freezer with a temperature of -20 degrees Celsius until it is needed.
As for the results and discussion of our experiment, so this is the first step, and it is the first of the first step, which is the starch isolation that we've conduct the experiment. So these are our photos of our experiment. It was cut into piece, and then it was set by Angeli for the steps, and we haven't finished it yet. Actually, it is around 2 or 3 steps behind from the actual bubuk, actual powder, and there are two. So after we get this powder, we need to obtain the starch, right? And so we need to pour the powder to the distilled water, and then we need to diamkan. We need to place it overnight, and then after that we can obtain the starch. So, but before that, we have two results, two powder color results, and which is why, like we wonder why, and then so we trace back from what we've did. So from the first trial, the more light brown than second trial powder, it has so when we conducted the experiment, we cut them into small pieces, smaller than the second trial, because the second trial was using like a lot more bonggol pisang, banana hump, and then we didn't think that it will affect the drying steps. And then we just go to expose it by sunlight, and it has the same amount of time. And at the oven time, we have problem in there. So the first one is actually the right one. We open it for 30 minutes at 60 degrees Celsius, while the second one, we intended to have a faster result using a higher degree of oven, hotter, and uh, it's it is written that 10 times 3. It means that for the first, we intended to take it only for 10 minutes, and then after we checked it, it is still moist, and then we put it again, and we check it again another 10 minutes, and it is still moist, and then we do it again 3 times. So after that, we grind it. But the first one, it shows nice dry nice dried powder, while the second one was not. It is still moist, so we do repeating process in drying and grinding until we get the dried powder result, and then it is filtered, and after that we get this result, which is the second trial, is the uh, darker one, because due to overheated from the oven. Like, it is actually the best way to dry natural materials. We're using 60 degrees Celsius. So for further plan, we still need to continue the steps, and we were trying. Right now, we're trying to finish it. And for our last presentation for biomaterial final test, we aim to reach the starch hydrolysis step, which is the next step. Conclusion.
So the conclusion is the first thing is biodegradable surgical suture will be fabricated from PLA, from banana hump, and then the PLA is created through hydrolysis, fermentation, and also polymerization. And PLA and glucomannan will be wet spinned to form suture, and the suture will be characterized based on viscosity and chemical structure. And that's all from us. Thank you.
So how do you spell that Spanish? Tienes alguna pregunta?
Gracias.
Is that Spanish or Portuguese?
Spanish, sir.
Spanish. Okay, so yeah, my comments are I think your presentations is too lengthy. You should make it shorter, especially when later. I don't know if the PKM later has also presentation session, but maybe you need to make it shorter. But now, as I take note of time, you spend 25 minutes to present all of the PPT. It's too long. Yeah, maximum actually 15 minutes. And the fabrication part, I think you should make it. But not the fabrication part. Yeah, the steps here. Don't write like this, because people will find it difficult to maintain concentration and then to understand. It is useful if you draw illustration instead. Yeah, draw illustration bigger, and then put some small text is okay, but in general as an illustration that will be easier to follow rather than like this now. Yeah, illustration with the arrow, yeah, to indicate the steps. Okay, so I will make a breakout room, and we will do one-on-one question and answer. Okay, it's for your individual mark. Your individual mark. So everyone's ready. would like to be the first by alphabetical order?
No, sir. Ladies first, sir.
So alphabetical order will be Andi first, yeah? Okay. Okay. Okay, Andi, so you are now in. I just have some small question, yeah. What do you understand about some two questions, maybe one or two questions? So how come? How does the? Can you mention in short why? So you mentioned you explain about the processing part. So what processing will affect what structure of the thing that you are making? Use the shares. You may use the whiteboard if you like.
Perhaps I'll just, I don't know, maybe show the presentation.
Okay.
Oh, sorry, sir. Wait. My battery is low.
Actually, you are not supposed to look at the presentation now. You have to just answer it. Okay.
Iya, sir. Biar berwarna sebenarnya. So as for the fabrication, I think what the thing that will affect our results later is I think this failure part 2,
Yeah.
where
Use the whiteboard. This is supposed to be the test. Yeah. Okay.
I don't know what should I would.
Yeah. What explain? If you don't need the whiteboard, it's okay.
Okay, so as I mentioned before, I think perhaps our failure on producing the second trial one will affect the darker powder one will affect our results because
No, I'm not asking about that. I'm asking about the type of process, the procedure that you are using to fabricate the PLA and why. What kind of structure does it make?
as for the whole okay, I think all of them matters, and
Yeah, I'm asking what are they? What are those processes? And what sort of structure do they make from the hump? What do those processes make change?
first of all, like we want to produce the starch, right? So from uh, from the structure of the banana hump, which are the water and carbohydrate, yeah, and in carbohydrate, like there is the uh, glucose structure, and we need to hydrolyze it so that it could change the into starch, which it consists of glucose and the mannose. Is it mannose?
Can you write down in the whiteboard what you just said while also explaining it?
First, it is like we need to obtain the. It is kind of hard not using mouse. Why not? Text? So we need to obtain starch, right? And then from starch, sorry, where is it? Okay. Uh, we need to obtain starch from glucose, and it consists of carbo and water. So after that, uh, from here, we do the what was it? After we chop it, we put it on the beaker to make it and then we tried it so that the water will reduce, and we focused on the carbohydrate part, and then from there we
Okay, time's up. So thank you. Yeah, I will move you out. Okay, and I will ask the next one. Okay, Anjali, are you there?
Yes, sir.
Yeah, I'm going to. Where's Andy? Yeah, Andy is just missing.
Why is it?
Andy.
Andy. Oh,
He just left the meeting. Just ask him to stay in the main session.
stay in the main session. Oh, yeah. Okay, he's in the main session, person.
Okay, now I will erase first. Okay, question for you. What main properties are important in this development of sutures, yeah, banana sutures? What kind of material property are important, and how do you measure them?
The properties of the materials that is important.
Yeah.
Because it is used as suture, so obviously it has to be biocompatible and biodegradable, so that it can be more. It's more practical. We don't have to take the sutures out again, and it has to be quite elastic, not very rigid, so that it doesn't break when it is used, and um, biodegradable, biocompatible.
So how do you measure biocompatibility and biodegradability?
The biocompatibility by testing on biocompatibility by testing on living cells, and it also it it also has to be apa ya? It has to promote cell viability, meaning that it can maksudnya it can accommodate living cells and does not is not harmful to them, and the cell viability can be tested on living things, like smaller living things, maybe like bacteria or bacteria. And what else? The property. Oh, and because it is a suture, it also has to, aside from being elastic, it also has to have a compatible tensile strength so that it is strong enough to hold the thing that we like sew together, but it does not break either.
Okay. How do you know how to measure mechanical strength?
Tensile strength using the apa ya? Yang alat the device is like sort of like a weight, like apa namanya ini pair spring, like a spring, and then we put the oh no, oh yeah, the spring, and then we attach the apa tuh namanya, the thread, and then we put some weight into it so that kayak ketarik gitu. Ada
Okay,
untuk
yeah. We have there is special machine to do that, and unfortunately we don't have that special machine in our lab yet. Maybe in the future, yeah. And for now we have to do it manually. So please study, review again what I have thought about that special machine. Okay. So please check again in your note or in the PPT that I have given, yeah, about mechanical properties testing. Okay, thank you, Anjali. So I move you to the main session and invite the next.
Thank you, sir.
Tunggu sebentar ya, kok yang dua nggak?
Halo, sir.
Anjali sama siapa namanya tadi? Andi is living.
No, masih ada kok, sir.
Not in the main session.
Iya.
Ada in the main session?
Iya.
Okay, wait one moment. Let me check in the main.
Okay.
Okay, you are still there.
Sir?
Yes, sir.
Yeah. Just wait here, yeah, later. I will come to the main session. I will go to the room again. Okay, Ezra, I have a question. So, can you explain again the process to develop a polymer? And how,
Okay.
from the theory, how does polymer develop and how is it being done in this particular project?
Okay, so because we use starch, the first thing that we have to do is isolate the starch. So after we isolate the starch, we have to hydrolyze the starch, and the hydrolysis can be there are two ways. The first one is by using enzyme and
before specific to starch.
Okay.
What
Okay,
is
to
polymer?
isolate.
What is polymer in general, and how do we make polymer, fabricate polymer in general first? Polymer, polymeric material.
Okay, because as we know, polymer is a component of monomer, and basically many polymers made from polymerization, and usually there are catalysts that are used to fasten the polymerization from monomer to polymer, and some of the catalysts use metals, but in this experiment we didn't use metals at all. We didn't use catalysis at all. We follow the previous research, is by heating, because why do we follow this method is because it's easier, and basically the open ring polymerization is needs a lot of tools, but in this polymerization it just need oven and also freezer, something like that.
So how do we control the polymerization?
Um,
When you use the polymerization process.
to control the polymerization is by using heat and sometimes heat, because first when we want to polymerize we heat it, but if we want to stop it we use cooler temperature, and also we dissolve it with chloroform so they don't do polymerization again, but also connect it to the chloroform, something like that, sir.
Okay, so you need to review again, your lecture notes on polymer, because it's
Yeah.
wait. It's not what I'm asking. I'm asking the process of initiation, polymerization, through radicals, and then the stopping.
Oh.
You still remember?
Oh, yes, sir. Yes, itu kan ada banyak macamnya juga.
Yes.
Kalau misalkan.
That's what I'm asking actually.
Okay. So, kalau
each of that step in the theory of the polymerization, how are they being done in your research, in your experiment? The initiation part.
Okay.
Radicalization, or what else?
Okay. So kan kalau misalkan polymerization ada initiation and then propagation and also termination. Kalau misalkan the initiationnya itu
in English.
Oh yeah, okay. So for the initiation, we did like the lactic acid is placed in the beaker glass and also it is heated for 1 hour. And then because lactic acid is really related to temperature, so it can bind when it is in 150 degrees Celsius. So we waited it for 24 hours because we didn't use catalyst and it took a longer time to make polymers. So the step where they bind is the propagation, and after that the termination, they stop when the temperature is cooled down, and also it is dissolved with the chloroform, so the apa namanya the chloroform and the other PLA will compete, and after that they will stop the polymerization, like that, sir.
Okay, thank you. That will be all for today. So please study again, because in the final exam, it may come again this question.
Okay.
Okay, Grace. So I have one or two short question. So you explain to me
Sorry, sir. I need the.
You need what?
No, I need the video because not tadi ada noise gitu. But yeah, I forgot to unmute it. Yeah, could you please
Yeah, can you hear me?
Yeah. Now I can hear you.
Okay. So the questions will be related to the sutures, as medical sutures. Biocompatibility is important. How can we assess biocompatibility?
by testing the with cell viability, like we put the sutures inside a cell culture, something like that. But for this for our research, we didn't include that because I think it's still not we're still not able to do it here. But yeah, that's how we assess the cell viability, the biocompatibility within the surgical suture and also the cells of the human
Okay.
body.
Next, what are other competing materials to be used for medical sutures?
I don't understand what are other.
What are other competing materials for medical sutures besides polymer, besides ELA?
There's something like the collagen suture, like the catgut suture, or yesterday I found polyglycolic suture, and then I forgot what's the name again, but yeah. Oh, there's also silk. Yeah, they might be absorbable or not absorbable. So yeah, the one that we're making is
So can you
absorbable.
compare their properties? Which one? How do we compare which one is better than the other? What properties do we compare between them?
First, it could be the mechanical properties. I think the synthetic materials have a more tensile strength, but yeah, they are not that they couldn't be absorbed by the human body. As for the natural the one made from the natural polymer or natural derived materials, they have a weaker tensile strength, but they are bioabsorbable. But yeah, so there are the advantages and disadvantages, and then also aside from that, the structure, also the morphology, I think it will also be different from the synthetic and the natural. And then also the place where the suture could also be different based on its usage gitu, kayak where will the doctor use that suture for, like is it for the internal organs or for the skin, or yeah, for something like that. And also the how to say it, kayak cara mereka menjahitnya gitu. I think it will also contribute to how the people produce different kind of sutures.
Okay, clear enough. So let's meet again in the main session. Okay, guys, so I have taken note of your session. So this will be part of your mark. Yeah. So please, for the final exam, so you will just present. Please revise again the way you present, and please send this current file. Later, I will make it in the Google Classroom, the assignment of this milestone. Just submit the PowerPoint and then submit also the peer review. Yeah, peer review means you review the other person's contribution to the current milestone. Okay, the PowerPoint cannot one person only submit is okay. So maybe let's say maybe only Ezra is also okay. While the each person need to submit the peer review. So yeah, again for your final exam presentation, please revise it and not too long. So maximum 15 minutes or 20 minutes is still fine. Yeah, I think 15 to 20 minutes, but not as until 30 minutes too long. And maybe I will ask Pak Hollis also to join the evaluation to assess you, and just like what we did just now, so that then each person can have individual questions. Yeah, so it means each of you needs to understand the whole experiment. Yeah, not even though one of you present only some part of the presentation, but each of you need to understand all, and also all of you need to read again the theories. Yeah, the theories biomaterial which I have taught and also part of Holly's taught. Yeah, from my side, maybe let's say related to especially polymer fabrication, polymer theory, and then also material properties like mechanical properties like that. Keempat college may be related to cell tissue interaction, biocompatibility, bio toxicity, etc., etc. Okay, and so it's like oral exam, something like that. Yeah, but so there will be a group discussion, but there will be also individual discussion. Yeah, so the individual question may not sometimes or many times may not be exactly about the current project, but related to the project. So I'm not asking only about starch or ELA, I will be asking about polymer in general, for example, or other medical sutures, for example. So please prepare also individually, so not only as a group, but each of you need to read again whatever we have been taught to you by me and Pak colleagues. Any questions so far? No? Andy? Yeah.
Papernya kapan bisa Pak?
Yeah, paper can be, let's say, when do you need, how much do you need time? So it's also for you also to prepare, right? like until so far. So to prepare, so that then by the end of the final exam, you already have some draft of manuscript to be sent, right? To fulfill the target of your PKM also, basically. May I ask, do you already have some target journal? To which journal you want to submit the final report of the final result of the PKM? Any idea?
To be honest, no. To be honest, sir, belum.
Not at all?
Masih.
No idea at all?
Kemarin cari-cari sempat kayak maunya di molekul, cuman kayaknya
Yeah, molecule is
cuman
quite
masih belum tahu juga.
Yeah, I mean, if you already have the intention to submit a specific journal, later then you make the draft of that manuscript for the milestone and also later for the final exam according to the template of the journal. Okay, so not from my template, but from the template of the journal. Okay, so you please, four of you, think and decide together which journal you would like to submit your report. Yeah, I think a good national journal like Molecule is will suffice. No need for now to submit to international journal by ACS. Of course, it will be much better if you can submit to ACS Biomaterial. All of you will get A plus if got accepted. But for now, I think it's too difficult. Yeah. So aim for national level journal. I think it will be good enough. Okay, no further question. If not, then that will be all for today. Thank you very much and all the best, success.